So this is one of the neatest questions in terms of how things simplify. So the first thing that you notice, of course, is that there are parentheses, so that means you have an inner function of 1 over x. So our inner function is 1 over x, leaving us with an outer function of secant inverse to differentiate first. So we have to use and memorize the derivative of secant inverse of x is as follows. So to apply this to get our derivative of our outer, we are going to replace all of the x's that are in this formula with the inner function, and that will give us the derivative of the outer. So in this case, I have x here, here, here. All of those in the formula are going to get replaced with the inner function. So this will be the derivative of secant inverse of 1 over x is now looking at like 1 over the absolute value of 1 over x, square root of 1 over x squared minus 1. Now that fraction is the derivative of the outer. Because we replaced all the x's in this formula, that gives us the derivative of our secant inverse. Now, we then have to multiply that, of course, by the derivative of our inner function. So when you think about 1 over x, that's your inner function, the quantity in parentheses. To differentiate that, you would have to move the x up into the numerator. So I would rewrite that as x to the negative 1, and then that would give us that the inner function is negative 1 x to the negative 2. Okay, now at this point it might seem like we are done, but actually the hard work is about to come here because we have to simplify this. So the first thing I always think about is anytime I have a negative exponent, I immediately pop that down into the denominator to make it a positive exponent or move it across the division line. So I'm going to move this x squared negative 2 down to the denominator to become an x squared. Then I'll be left with 1 times negative 1 in the numerator. Now I still have this denominator here that is a little hairy in order of trying to simplify it. So first thing is that the absolute value of 1 is just 1. So we can drop the absolute values around this numerator. In the denominator, we don't know if x is positive or negative. So we do have to keep those absolute values around that x. All right, now inside of this radical, we have an exponent with parentheses. So I want to distribute that to the numerator and the denominator. If I take 1 squared, that's just going to give us 1 over x squared minus 1. Now, hopefully it's pretty clear at this point. Inside this radical, you have a fraction minus an integer, so you want to get a common denominator. So that common denominator will be x squared, so I multiply by x squared over x squared. All right, so let's see if that helps us any here. We have negative 1 over 1 over absolute value of x. And then we have inside this radical now 1 minus x squared over x squared times x squared. All right, so radicals, if you have multiplication or division, you can split up the radical. So this division inside the radical can be split up into the radical of 1 minus x squared over the radical of x squared. Now, that is then multiplied by 1 over absolute value of x and then times x squared. Now, here is where we get the opportunity to really use a lot of our absolute value properties. So recall that one of our absolute value properties is that if you have the square root of x squared, that is actually equal to the absolute value of x, because this x could be positive or negative, and when we square it, we would get a positive. All right, so here's the situation. The square root of x squared, that we are going to say, okay, that is just the absolute value of x. Now, the question is, do these two absolute values somehow combine with this x squared? So here we really have to think about this. So we have negative 1 over the square root of 1 minus x squared over the absolute value of x times the other absolute value of x. Now, if you have an absolute value times another absolute value, you have the absolute value squared. So I have the absolute value squared and then times x squared here. Okay, now remember that the whole purpose of the absolute value is to make the quantity positive. So if you think about squaring something, this expression here, because you're squaring it, is always going to be positive. So are the absolute values really necessary? They're not. So because this square means it's always positive, the absolute values can be dropped. And that's very exciting for us because if we drop those absolute values, we will have -1 over the square root of 1 minus x squared over x squared. And then that can cancel out with this x squared that we had here. So then these guys cancel, and then we are looking at our derivative, a very elegant answer, y prime is equal to -1 over the square root of 1 minus x squared. Okay, so you just got to kind of sit there and think about where you came from and how you got to this. We started here with all of this, and we were somehow able to simplify it down to this. So that is a very beautiful operation that just happened there. And I really want you to get out of this square root of x squared, recognize that as an absolute value. And then the second thing to really understand is that you can drop these absolute values because you're guaranteed that that quantity is going to be positive.